All right, this is the start of our Test 1 notes packet. We're going to go over Module 1, Homework 1 notes. In this section, we're going to solve linear equations. We're going to talk about what the word linear means in a minute, but for this first example, let's solve for x. So solve means we're going to get that variable by itself. So we're going to get x by itself. Our example here is negative 7x minus 2 equals negative 65. So there's two sides of the equation. The left side with a negative 7x minus 2, and then the equals breaks our equation into two sides, the negative 65. So a lot of people really like to see the visual of the left side of the equation and the right side of the equation. And I want to get that x completely by itself. A lot of people have trouble of what do I do first? Do I move the negative 7 or do I move the negative 2? So go back and remember your order of operations. So let's write this over here to the side. Our order of operations. So for our order of operations, we have our good old PEMDAS. So please excuse my dear Aunt Sally. So what that means is we have P for parentheses. Again, please excuse my dear Aunt Sally. That's what I learned. However you learned it, PEMDAS. Our order of operations. So P stands for parentheses. E stands for exponents. M stands for multiply. D stands for divide. A is for add, and S is for subtract. Now, before we go further, let's talk about a couple things. Multiplying and dividing are essentially the same thing. For example, if you do half of something, in order to get half of something, you can multiply by 1/2, or you can divide by 2. Either way, you're still getting the half of it. You're still doing the same thing. Likewise, adding and subtracting are the same thing. If you want to subtract 2, that's the same thing as adding negative 2. So for these two things, you're going to do that in order from left to right. So just keep that in mind. So whenever we simplify an equation, we're going to work our way down the list. So whenever we simplify, we're going to start off by clearing our parentheses. Then we're going to clear our exponents. Then we're going to get rid of our multiplication and division from left to right, because we read from left to right. And then we're going to add and subtract, again in order from left to right. But now we're working opposite. Now we're trying to solve the equation. We're trying to work backwards to undo some stuff. So whenever we're solving, we're going to work backwards up the list. So whenever we're solving, we're going to work backwards up the list. So that means we need to first get rid of our adding and subtracting. So if we have negative 7x minus 2, the negative 7 is multiplying the x. So negative 7 times x. And then this negative 2 is being subtracted. So negative 7x minus 2. So we need to first get rid of that minus 2. So we can get rid of that minus 2 by doing the opposite to cancel it out. So that means we can add 2. The opposite of subtracting 2 is adding 2 to both sides. Now, some of you, I just want to take a little note here. I'm trying to break it down as basic as possible. So that way, if you need it, great. If this is too basic for you, that's fine. I'm just trying to make it where we're going to start off super basic and then go and get it more complicated. Because this is something that's foundational for the course. So just keep that in mind. So negative 2 plus 2 goes to 0. So that cancels out. And we're left over with just that negative 7x equals negative 65 plus 2. So negative 65 plus 2 will give us negative 63. Negative 65 plus 2 will give us negative 63. You can use your calculator for that if you need to. So now that we got rid of our adding and subtracting, we now need to get rid of our multiplying and dividing. So I have negative 7 times x. So to do the opposite, to get rid of that negative 7 times x, we're going to do the opposite. We are going to divide. The opposite of multiplying by negative 7 is dividing by negative 7. What you do to one side, you have to also do to the other. So we're going to keep this equation balanced, and we're going to divide by -7 on both sides. That way, -7 divided by -7 cancels out. -7 divided by -7 is 1. We're left over with 1x. 1x is just x equals -63 divided by -7 will leave us with +9. We got x by itself. We simplified, done. Our answer here is 9. Let's do another one. So solve the equation for the given variable. So x over 8, x divided by 8 minus 7 equals 7. So going back again, we're solving, so we're working backwards. So x is being divided by 8, and it's also being subtracted by 7. We have two sides of our equation, so I'm going to draw a line to really show those two sides. So getting x by itself, first we're going to solve, so we're going to work our way backwards up the list. We are going to get rid of our adding and subtracting. So if we have -7, we are going to do the opposite. We are going to add 7 to both sides. Let me get a different color here. I'll keep it. So we are going to get rid of that -7. So we're going to do the opposite. We are going to add 7 to both sides. That way, -7 plus 7 goes to 0. Those cancel each other out. So we are just left over with x over 8 equals 7 plus 7, which will leave us with 14. X over 8 equals 14. So again, we got rid of our adding and subtracting. Now we need to get rid of multiplying and dividing. So what's happening to 8? I'm sorry, what's happening to x? X is being divided by 8. So the opposite of dividing by 8 is multiplying by 8. So we are going to multiply both sides by 8. That way, our 8's cancel. 8 divided by 8 goes to 1. We are left with 1x, which is just x. So we have x by itself, which is what we wanted. X equals 14 times 8. 14 times 8 would give us 112. Again, use your calculator. So x equals 112. We got x by itself. Boom, we're done. We are good to go. All right, so like I said, we're just going to keep adding each time, adding on. These examples come straight from your homework, so you should see something super similar on your homework. Let's do our next example. Solve the equation 7x minus 4 equals 2x plus 9. Now we have a variable, we have an x on both sides of our equation. Write your answer as an integer. Integer just means a whole number. Or a reduced fraction. So reduced fraction just means to simplify. Do not use mixed numbers. So mixed numbers mean something like, I don't know, like 2 3/5. So you don't want 2 3/5. You don't want the whole number and the fraction. You just want to leave it as a fraction. So for example, that would be 2 times 5 is 10 plus 3, so 13/5. So this is a mixed number. And this is a improper or a reduced fraction. So this is what we want. We don't want the mixed number. 2 reasons. This does more for us with algebra than this. Second reason, this is more work. We're gonna get our answer like this. I don't want to do more work and putting it as a mixed number. Just leave it as is and you're good to go. We have plenty of work. We don't need to add on more to our plate. All right, so our equation here, 7x minus 4 equals 2x plus 9. 7x minus 4 equals 2x plus 9. All right, again, we have two sides of our equation. And I want to get x by itself. Before I can get x by itself, we need to get our x's together. So we have an x over here and an x over here. So let's move this x, the 2x, over to the other side with the 7x, combine like terms, so that way our x's are together. So if we have 7x and 2x, let's move this 2x over here with the 7x. So it's positive 2x, so I need the opposite to move it across the equal sign. So I needed the opposite to move it to the other side of the equation. The opposite of positive 2x is negative 2x. So let's subtract 2x from both sides of our equation. So that way 2x minus 2x goes to 0, those cancel out. So we're left over with 7x minus 2x, combining like terms. 7x minus 2x would give us 5x minus 4, that stays the same, equals our 2x's canceled, so we're left over with that positive 9. All right, so now this looks like the previous problems we did. We got our x's together, which is great. So now let's try to get it by itself. 5x minus 4 equals 9. So let's get rid of our adding and subtracting. So let's get rid of that minus 4. So the opposite of minus 4 is going to be adding 4. We can add 4 to both sides. Negative 4 plus 4 goes to 0. Those cancel out. We're left over with 5x equals 9 plus 4, which would leave us with 13. All right, almost done. We have 5x. This means 5 times x equals 13. Excuse me. So I want to try to get x by itself. So the opposite of 5 times x would be to divide by 5. So let's divide both sides by 5. So that way 5 divided by 5 cancels out because we're left over with 5 divided by 5 is 1. We're left over with 1x, which is just x, equals 13 over 5, which is weird because I did not know that was going to be the answer whenever I did this example. But 13 over 5. Maybe that's a sign that I've done this too many times. We always want to reduce it or simplify it. So looking at 13 and 5, there's no numbers that go into both of them evenly. There's no numbers that are divisible by 13 and 5. So it cannot be simplified. So done. So our answer is just 13 over 5. Notice I'm boxing in just the 13 over 5, not the x. So whenever you put this into your homework, don't put x equals. Just put in the number. Just put in 13 over 5. All right, let's keep rolling. So next page. All right, so again, we're going to add on a little bit each time. So solving the equation, 7 times 2v plus 1 equals 35. Focus it so it'll get a little blurry for a second. All right, so 7 times 2v plus 1 equals 35. So a couple different ways you can go about this. Usually what people do whenever they see the parentheses is they want to distribute, which is totally fine. So let's go ahead and distribute. So let's distribute that 7. So what distributing means is we are going to take that 7, because it's distributing its multiplication, and we are going to distribute it or multiply it to everything that's inside the parentheses. 7 is outside the parentheses, that means it's going to be multiplied to everything inside the parentheses. So let's go for it. So 7 times 2v would leave us with 14v. 7 times 1 would leave us with positive 7 equals 35. So we have 14v plus 7 equals 35. All right, so going back to what we did earlier, going back to our order of operations, we want to get rid of our adding and subtracting first. So let's do it. So 14b plus 7 equals 35. Again, if you need to really highlight your two sides of the equation, go for it. Let's get rid of our adding and subtracting. So let's get rid of that plus 7. The opposite of adding 7 is going to be subtracting 7. So we're going to subtract 7 from both sides of our equation. That way 7 minus 7 goes to 0. Those go away, they cancel out. We are left over with 14b equals 35 minus 7. 35 minus 7 is 28. Use your calculator. So we're left over with 14b equals 28. Almost done. It's 14 times b, so we need to get rid of that 14. So the opposite of multiplying by 14 would be dividing by 14. So let's divide both sides by 14. 14 divided by 14 goes to 1, which means they cancel out. We're left over with 1b, which is the same thing as just b. I don't need to write that 1 in front. Equals 28 divided by 14. In our calculator, 28 divided by 14 will leave us with 2. That's our answer. So b equals 2. We got b by itself. We are good to go. The answer is 2. Again, in the homework, just put 2. All right, we're getting a little bit more complicated as we go. Let's keep rolling. Solve the following. Negative 2 times d plus 9 minus 11d equals negative 13d minus 18. Again, what a lot of people do is they see the parentheses and they want to distribute, which is totally cool. Let's go for it. Let's distribute. So let's distribute that negative 2. The negative 2 is out front of the parentheses. That means it's going to be distributed. It's going to be multiplied by everything that's inside the parentheses. So let's go ahead and distribute that negative 2. Let's multiply everything by negative 2. So negative 2 times d would leave us with negative 2d. Negative 2 times positive 9 would leave us with negative 18. Now that's all that's in parentheses, so we're done distributing. Nothing else gets distributed by that negative 2. Everything else stays the same. So minus 11d equals negative 13d minus 18. Great. So, couple things. I see that we have d's everywhere. We got a d here, d here, d here. Negative 2d, and then we have a negative 11d on the same side. So let's go ahead and let's combine those like terms. Let's combine the like terms. Oops. All right, so if you notice that the negative 2d and the negative 11d are on the same side of the equation. So because they're on the same side, we just combine them together. The only time we do the opposite is whenever it goes to the other side of the equation. Because these two are on the same side of the equation, we're just going to combine them together like normal. So negative 2d minus 11d, negative 2d minus 11d, they're the same sign, so that means we're going to add them together and keep the sign. So negative 2d minus 11d would leave us with negative 13d. That minus 18 stays the same, equals negative 13d minus 18. Looking at this, I see negative 13d minus 18 equals negative 13d minus 18. Same thing on both sides, which you can stop right here if you want. Let's pretend, because I know sometimes whenever I'm doing homework, I just kind of like get in the groove and I'm just like, I might not have noticed that. So let's pretend you didn't notice that. Let's keep going. So let's get our d's together. So I have negative 13d on this side and I have negative 13d on this side. Let's move this negative 13d over to the other side with the other negative 13d. Because we're crossing that equation sign, we're crossing from one side of the equation to the other side of the equation, this is when we do the opposite. So negative 13d, the opposite would be adding 13d. So let's add 13d to both sides. what you do to one side, you have to do to the other to keep it balanced. That way, negative 13d plus 13d goes to 0, so that cancels out. Same thing over here. Negative 13d plus 13d cancels out too, goes to 0. So we are left over with negative 18 equals negative 18. Now we're stuck. So now hopefully you notice that they're the same things. So we are left with a true statement. Negative 18d does equal, I'm sorry, negative 18 does equal negative 18. So this is a true statement. That is a true statement. So that means whatever I plug into D, no matter what, whenever you plug it in, it's going to give us the same thing on both sides. You can plug in any number. Plug in 2, plug in 5, plug in 100, plug in negative 2, negative 5, plug in decimals. Doesn't matter. Whatever number you plug in is going to work. It's going to give us the same thing on both sides. So that means our answer for D can be any real number. So our answer will be all real numbers. So you might be like, okay, how do I put in all real numbers as an answer on the homework? So on the homework, let me write a little note over here. I'll move the paper over here in 1 second. So on our homework, it will be multiple choice. And one of the multiple choice options will say the solution set is squiggly bracket D such that D is a real number. My squiggly brackets aren't the greatest, but you'll get the point. So this is what's called set notation. We're going to talk about this a little bit later. The squiggly brackets just mean that's our set, that's our answer. The D is the variable that we're using. This vertical bar means such that. So our variable is D, such that D is a real number. So that's what our answer will look like. Again, it'll be multiple choice, so don't worry about memorizing this. It'll be multiple choice and just click on that option whenever you get a true statement. All right, let's try another example. So solve the following. 5 plus 2 times 6x plus 4 equals 12x minus 7. All right, again, we see this parentheses situation happening. So there's a positive 2 in front of the parentheses. Let's go ahead and distribute that positive 2. Let's distribute. So this positive 2 is the only thing outside of our set of parentheses. So that's the only thing that's going to be distributed or multiplied to whatever's inside the parentheses. All right, so we have 5 plus, let's distribute 2 times 6x would give us positive 12x. 2 times positive 4 would give us positive 8 equals 12x plus 7. I don't like when I do my 2 different. Sorry, maybe that's a little OCD. And that's a bad 2. Okay, maybe it's very OCD, don't judge. There we go. So 5 plus 12x plus 8 equals 12x plus 7. All right, again, I noticed there's a bunch going on. So I noticed, just like we did at the previous example, we can combine some like terms. Because I noticed I have 5 plus 8. Those are just numbers. I can add them together. Notice they're on the same side of the equation, so don't do the opposite. Just combine them like normal. So let's combine some like terms. So we're going to combine some like terms. So we're left over with 12x plus 5 plus 8. 5 plus 8 is 13. Equals 12x plus 7. Now you might look here and be like, okay, 12x plus 13 is not going to equal 12x plus 7. They're not the same thing. But you're right. Just like we said up here, once you see that it's a true statement, you could stop and say, okay, it's a true statement. It's the same thing on both sides. Let's keep going. This is a little bit harder to tell, so let's keep going. So let's move our x's together. I have 12x on both sides. Let's move this 12x over to the other side of the equation. It is positive 12x, so the opposite would be negative 12x. So let's subtract 12x from both sides of the equation. 12x minus 12x goes to 0 and cancel it out. Over here, 12x minus 12x goes to 0 and cancels out. We are left over with 13 equals 7. Okay, so we got rid of our x's, and we're just left over with 13 equals 7. 13 does not equal 7. That is a false statement. False statement. So what that means, it doesn't matter what you plug in for x, nothing's ever going to work here. So because nothing's ever going to work, there's no solution. Which in math, we are efficient. I used to say lazy, but now I say efficient. We are efficient. So instead of writing out no solution every time, we came up with a symbol for that. I say we, like I'm taking credit. I don't know, some probably old Greek guy came up with it. So no solution looks like this. So it's like a 0 with a line through it. That symbol is what's considered no solution. So be careful. Don't write your zeros. I know some people like write their letters or numbers a little different. Don't write your zeros like this because this is not a 0. This means no solution. So again, on the homework, just like we did on the previous problem, we would say the solution set. Again, it'll be a multiple choice option. So the multiple choice option is the solution set is what's called empty set. Our set of solutions are empty, which means there's no solution. Done. All right, so to summarize, there's 3 types of solutions we came up with. Up here, we got just one single unique solution. We got b equals 2. B equals 2. So we got unique solution, the variable x equals, or in the other case, b equals. So we got x equals 3, for example, x equals 5. Up here, b equals 2, just a normal solution. Our next option is whenever we got a true statement, just like this one. We got negative 18 equals negative 18. That's a true statement, so our answer is all real numbers. Another example, 0 equals 0, 5 equals 5, true statements, so all real numbers will work for our solution. Last but not least, just like this one, we got 13 equals 7, which is a false statement, so that means no solution. It's like 5 equals 0, not true, false statement, so no solution. Negative 2 equals 3, not true, false statement, so no solutions. Those are our 3 different types of solutions that we have. All right, so now that we're talking about solving equations, this course is all about taking something and then adding on a little piece, adding on a little piece, adding on a little piece. So let's add on another little piece. So that's equations. So everyone's favorite, fractions. I can sense your enthusiasm all the way from here. So fraction review. We're going to add fractions to the mix because we're adding fractions to the mix, and I know everyone loves fractions. Let's go ahead and do a quick fraction review. Let me focus it again just so it looks a little blurry. A fraction review so that we will all start off on the same page. So note, this is kind of important that we'll use down the road. A negative sign in front of a fraction can be rewritten as a negative sign, just the numerator. The numerator means the top of the fraction. Or a negative sign, just the denominator. The denominator is the bottom of the fraction. And that just helps us keep it organized. We are doing algebra. We're manipulating the equation. So it's kind of like we can take that negative and put it wherever we want it. So for example, negative 3 over 4, negative could be outside. Or we could move it to the top and say negative 3 divided by positive 4 is still negative 3/4. Or we can move it to the bottom and say positive 3 divided by negative 4 is still negative 3/4. So all of these 3 things mean the same thing. It's just whatever helps you with your particular equation. A lot of times I move it to the top or the bottom also so I don't forget it, because a lot of people can easily forget a negative sign. Don't do that. All right, so let's multiply. Let's talk about multiplying fractions. That's better. All right, so let's multiply, for example, 3/5 times 1/2. 3/5 times 1/2. So we're going to multiply fractions by multiplying straight across. Let me use. So we are going to multiply straight across. Multiply straight across. So what that means is top times top, bottom times bottom. So multiplying straight across, top times top, bottom times bottom. 3 times 1 would give us 3. On the bottom, 5 times 2 would give us 10. That's it. We're left with 3/10. Always try to simplify fractions if needed, but there's nothing that 3 and 10 have in common. So we can't simplify it any further. So our final answer is just 3/10. Done. All right, let's do another one. All right, this is easy again. Sorry. So 3/10. My pencil keeps on hitting this. All right, 3/10. All right, so let's divide. So dividing fractions, there's a couple different things that people say. So however you were taught it in the past, however you do it is fine, as long as you do it the right way. So dividing, what we're going to do is multiply that by the reciprocal. Multiply by the reciprocal, which is just a fancy way of saying multiplying by the flipped fraction. So what we're going to do is keep it, change it, flip it. So keep, change, flip. Or sometimes I hear a lot of say change, flip. It's all the same. So what we're going to do is we're going to keep the first fraction the same. So if we have 3/5 divided by 1/2, so we're going to keep that first fraction the same. So we're going to keep 3/5 as 3/5, 3/5. We are going to change our operation. So that means we're going to change it from division to multiplication. And we are going to flip that last fraction. The flipping is what makes it the reciprocal. So we're still multiplying by the flip or multiplying by the reciprocal. So flipping 1/2, that would give us 2/1. So now we have 3/5 times 2/1. Now we're multiplying. So just like up here, we're going to multiply straight across. So multiplying straight across, 3 times 2, straight across, 3 times 2 would give us 6 over, straight across, 5 times 1 would give us 5. So 6/5, let's see if we can reduce it. There's no number that 6 and 5 have in common. So it's okay that it's improper. It's okay that 6 is bigger. Just leave it. Our answer is 6/5. All right, so that's multiplying and dividing. Let's talk about adding and subtracting. So for adding, we have 3/5 plus 1/2. I have fifths and I'm adding halves. That's not the same thing. These are not like terms. So in order to add fractions, we have to make these like terms. We have to make these the same thing. So to do that, we have to get a common denominator. So get common denominator. Get a common denominator. Again, remember at the top, that denominator was the bottom of the fraction. So I want the bottom of my fraction to be the same for both fractions. So I want my denominator to be the same. So if I have 3/5, I'm just going to rewrite it, 3/5 plus 1/2. I want my denominators, my bottoms, to be the same. So what number could I make 5 and 2 both into the same number? So in other words, I want to multiply some number, any number, by 5, and I also want to multiply another number by 2, so that way these two numbers are the same. Well, looking at it, I can make both of these numbers 10. I can do 5 times 2 to give us 10. I can do 2 times 5 to give us 10. So that means our common denominator, which we're going to call our LCD. We're going to talk about LCD in just a second. So our LCD, which is our least common denominator, our smallest number that we can make them both into, our LCD is going to be 10. Our least common denominator is going to be 10. So in other words, I can multiply the top and the bottom of this first fraction by 2. Notice I'm multiplying the top and the bottom. Reason being, I'm able to do this because what you do to one side, you have to do the other, yes, but I'm multiplying by 2 over 2. 2 divided by 2 is just 1. So I'm really essentially multiplying by 1. I'm multiplying by a fancy way of writing 1. That means I'm not changing the quantity, I'm not changing the amount, I'm just changing the way it looks. So 2 times 3 would give us 6. All over 2 times 5 would give us 10. So 3/5 is just a simplified version of 6 over 10. So again, we're not changing the quantity, we're just changing the way it looks so that way we can manipulate it and make it how we want it. First fraction's done. Other fraction, I have 1/2. I want my denominator, the bottom, to be 10. So in order to make 2 into 10, I need to multiply by 5. What you do to one side, do to the other. Also, I need to make it even. So I'm multiplying by 5 divided by 5. 5 divided by 5 is just 1. So that way I have 1 times 5 is 5. All over 2 times 5 is 10. So now I have 6 tenths plus 5 tenths. So now I have tenths that I'm adding together. So now I can combine those like terms, combine my tenths. So if I have 6 tenths plus 5 tenths, 6 things plus 5 things would give me 11 things. So 6 tenths plus 5 tenths is 11 tenths. 11 tenths. So we cannot reduce or simplify 11 over 10. There's no number that 11 and 10 have in common. So done, final answer. Let's do the same thing for subtracting. So subtracting 3/5 minus 1/2. Notice I use the same number so that way we can kind of speed this up a little bit. Adding and subtracting are essentially the same operation. So we're going to also get a common denominator. Get common denominator. All right. If we have 3/5 minus 1/2, again, we want to turn these bottoms into the same number. We have fifths and we have halves. They're not like terms. I want to make them like terms. I want to make them the same thing. I can make 5 and 2 into 10 by multiplying. So our LCD, our least common denominator, will be 10. If we have 3/5 minus 1/2, just like we did up here, I can multiply that first fraction by 2 on the top and the bottom. So that would give us 2 times 3 is 6 over 2 times 5 is 10 minus, I can multiply the second fraction by 5 on top and the bottom, just like we did up here. So multiplying by 5. That would give us 5 tenths, just like we did previously. So now we have 6 tenths minus 5 tenths. So now they're both tenths, they're both like terms. 6 tenths minus 5 tenths would leave us with 1/10, which is simplified. So that is our answer. All right, so that's adding and subtracting. We mentioned this LCD thing. So LCD stands for least common denominator. LCD stands for least common denominator. Least common denominator. So what a least common denominator is the smallest number to turn both denominators into. And remember, whenever I say to turn, this is going to be using multiplication. So I want to multiply both fractions, top and bottom, by something to make both of my denominators the same. Remember, the denominators are our bottoms of our fractions. So it's the smallest number. I can turn both denominators, both 5 and 2, we turned them both into 10 using multiplication. All right, so some of us, just like this one, 5 and 2, we can turn into 10. That was an easy one. What if we have something that's not so easy? Let's see what we do behind the scenes to make this work. Because like I mentioned earlier, we're always going to take this concept and then add on to it and make it more complicated and more complicated. So if we understand what's going on behind the scenes, it'll make it better. So find the LCD, the least common denominator, for 8 and 36. Some of you might know it off the top of your head. Totally cool, good for you. But let's see what's going on behind the scenes. All right, so if we have 8 and 36, let's see what are our different options that we can turn 8 into using multiplication, and we can turn 36 into using multiplication. So we have 8. So I can do, let's say 8 times 1, which is 8. We can do 8 times 2 to give us 16. We can do 8 times 3. We can do 8 times 3 to give us 24. So 24 is an option we can turn it into. We can do 8 times 4 to give us 32. We can do 8 times 5 to give us 40. Again, we're just looking at all the different options that we can turn 8 into using multiplication. I can multiply by some number to give us this option. So 8 times 6 would give us 48. We could do 8 times 7 to give us 56. We can do 8 times 8 to give us 64. We can do 8 times 9 to give us 72. We can do 8 times 10 to give us 80. And so on and so forth. We'll just stop there. These are just our different options. It could keep going though. So let's do the same thing for 36. So 36 times 1 would give us 36. 36 times 2 would give us 72, which I notice, hey, I have 72. That's the smallest number they both have. So that will be our LCD, but let's, keep going. So 36 times 3 would be 108. 36 times 4 would be 144, so on and so forth. But like we said, we see that, hey, they both can be turned into 72. I can do 8 times 9 to give us 72, and I can do 36 times 2 to give us 72. That's the smallest number I can turn them both into, so that would be our LCD. So our LCD would be 72. So that's how we would find our LCD, if you didn't know it right off the top. So let's use our LCD and let's put it together. All this fractions review that we just did, let's put it together with the solving equations that we did previously and put it all together in one equation. So next page. This is a long section, sorry. Don't shoot the messenger. All right, solve the following. 2/3 plus 2/3 times x plus 1 equals 1/6. So just like before, but now we've added on the concept of fractions. So there's parentheses, just like we talked about before. Let's go ahead and distribute those parentheses. So 2/3, positive 2/3 is in front. So let's distribute or multiply it to everything in the parentheses, the x and the 1. So let's distribute. So we have that 2/3 from right here. So that's just coming down. So 2/3 plus 2/3 times x is just 2/3 x. 2/3 times 1 is just 2/3. So plus 2/3 equals 1/6. So you have 2/3 plus 2/3 x plus another 2/3 equals 1/6. All right, so we got stuff everywhere. Let's simplify this a little bit by combining like terms. So we have a 2/3 plus a 2/3. Thankfully, they're on the same side of the equation, so we're just going to combine them together. And here, let me put here, combine like terms. Thankfully, they are like terms. They're just numbers you can add. But even further, they have common denominators, so that makes it even easier for us. So going back, remember, whenever you add fractions, we are going to get that common denominator. You're going to add the top, so 6 plus 5 gave us 11. But notice your bottoms stay the same. If you have 6/10 plus 5/10, you're left over with 11/10. So 2/3 plus 2/3, they're both thirds, so they're like terms. I can combine them together. If I have 2/3 plus 2/3, that would give us 4/3 total. So notice that thirds on the bottom is going to stay the same. So we have 2/3 x plus 2/3 plus 2/3 would give us 4/3 equals 1/6. All right, so now we did that part. So now I look at this and I'm like, man, this would be so much easier if I didn't have fractions. So let's get rid of them. So if I have, let's get rid of our fractions. So fractions mean divide. This is saying 2/3, which is saying 2 divided by 3. So in order to get rid of something, we do the opposite. So what's the opposite of dividing? Multiplying. So let's multiply by the LCD to get rid of our fractions. Multiply by our LCD to get rid of our fractions. Right back here. So we're going to multiply by LCD to get rid of fractions. All right, so let's find our LCD. So if we have thirds, and 6, I have 3, 3, and 6 as our denominators. I want to make all these denominators the same. So, sorry, I want to make all my denominators the same. So I can make 3, 3, and 6 all into 6, and then they'll be all the same. So our LCD here would be 6. So I'm going to multiply everything by our LCD, which is 6. Now we're multiplying fractions. So the 6 is going to be multiplied to every term inside the parentheses. If you notice, though, I have fractions times fractions. How do we multiply fractions? Going back to that previous page, we're going to multiply straight across. Top times top, bottom times bottom. But there's not a bottom here. I just have 6. But 6 is the same thing as just saying 6/1. Because 6 divided by 1 is just 6. That way we can distribute fractions times fractions. So let's go for it. So I have 6, or 6/1, times 2/3 x. So we're multiplying fractions. We're going to multiply top times top, bottom times bottom, multiply straight across. So 6 times 2 would give us 12. Divided by 1 times 3 would give us 3. X, so 12/3x. Plus, same thing, 6 times 4/3. So top times top, 6 times 4 would leave us with 24. All over 1 times 3, which would leave us with 3, equals 6 times 1, 6. So top times top, 6 times 1 would give us 6. Divided by bottom times bottom, 1 times 6 would give us also 6. Now you might be like, okay, she's crazy because we did not get rid of our fractions. And you're right, but once we simplify, our fraction should go away nicely. So our next step should be to simplify. So let's see. And if they don't go away nicely, you did something wrong. So go back and check your work. So 12 divided by 3. 12 divided by 3 is just 4, so 4x. Plus 24 divided by 3, which is 8. Equals 6 divided by 6, which is 1. Boom, this is so much easier. We're left over with 4x plus 8 equals 1. Now we can solve this just like a normal equation. We have two sides of the equation. I want to get x by itself. Let's get rid of our adding and subtracting first. Let's get rid of this plus 8. The opposite of plus 8 is subtracting 8. So let's subtract 8 from both sides. That way 8 minus 8 cancels out, goes to 0. I'm going to move over here. I'm running out of room, sorry. So we have 4x equals 8 minus 8 goes to 0, cancels out. 1 minus 8. 1 minus 8 would leave us with negative 7. Almost done. I have 4 times x. So in order to get x by itself, I'm going to do the opposite. And the opposite of 4 times x would be dividing. So let's divide both sides by 4. That way 4 divided by 4 goes to 1, cancels out. So we're left over with 1x, which is just x, equals negative 7 over positive 4, which is what we said earlier. You can either write it as negative 7 divided by positive 4. You could write it as 7 divided by negative 4, or a lot of times they want you to write your final answer like this first way, of that negative out front. So negative out front, so negative 7/4 will be our final answer. Negative 7 over 4. So same thing as usual, we just had that one extra step of getting rid of our fractions. All right, let's do a couple other equations. So now that we're getting more used to solving equations with numbers, let's throw a wrench in it. Let's solve equations using letters. Same exact thing. So people see this and get freaked out. We're doing the same thing, so don't get freaked out. So solve the formula for P. So we're trying to get P by itself. So we have S equals P times 1 plus RT. Now, we're trying to get P by itself. A lot of people see parentheses and they automatically want to distribute. That's why I put this example on our notes. Don't distribute, because then I would get my P's in two places, but I want to try to get P by itself. So think about what's happening to P. P is being multiplied by 1 plus RT. So I want to get P by itself. What's the opposite of multiplying by 1 plus RT? Dividing. So let's divide both sides by 1 plus RT. 1 plus RT. That way 1 plus RT cancels out. 1 plus RT divided by 1 plus RT goes to 1, cancels out. And we're left over with, on the left-hand side, S over 1 plus RT equals P. We got P by itself. If you want to switch it around, go for it, doesn't matter. So P equals S over 1 plus RT. Done. We got P by itself. We're done. Be careful on the homework. Notice that my S is capital. So in your answer, your S should be capital. My R should be lowercase. My T should be lowercase. So be careful. If it's upper or lowercase in the question, do the same thing in your answer whenever you put it into your homework. There we go. All right, one more for this page. So solve the equation y equals 9 divided by 3 minus x. And we're trying to get x by itself. So I'm just going to rewrite it. So y equals 9 over 3 minus x. I only have one x, so that's good. But I notice it's on the bottom of my equation. So I want to get it to the top of my equation so I can get it by itself. So we have 9 divided by 3 minus x. Let's multiply both sides by 3 minus x, and that way we can move it to the top of the equation. So instead of dividing by 3 minus x, let's do the opposite. Let's multiply by 3 minus x. That way my 3 minus x's cancel out. All right, so we're left over with 3 minus x times y equals 9. All right, a couple of different options. A lot of people see the parentheses and they think distribute. Totally cool. Let's distribute. So this y is outside of the parentheses. So this y is going to be distributed or multiplied to everything inside the parentheses. It's okay that it's behind. We're multiplying. You can multiply in any order. So if you want to put it in the front, that's fine too. If you like that better, to say y times 3 minus x equals 9. Y times 3 minus x equals 9. If this is the same thing. So either way, you do you. So y times 3 would give us 3y, minus y times x would give us xy, x times y equals 9. Alrighty. So again, we want to get this x by itself. I want to get that x by itself. So just like before, we have two sides of our equation, if that kind of helps you visualize it. So I want to get rid of my adding and subtracting. So I have 3y out front. That's being, you could say added or subtracted. This 3y is positive. So what's the opposite of positive 3y? Negative 3y. So we can subtract 3y from both sides. So this negative here goes with the x. The sign for the 3y is positive. The 3y is positive. So now if I have positive 3y minus 3y, that goes to 0 and cancels out. We are left over with negative xy equals 9 minus 3y. Now I have 9 and I have 3y. These aren't the same thing. These are not like terms. I can't combine it. Just leave it just like that. Almost done though. So we're trying to get x by itself. So I have negative, which is like saying negative 1 times x, negative x, times y. So the opposite of multiplying by the negative and the y is dividing. So let's divide both sides by the negative and the y. That way the negatives cancel out and the y's cancel out. What you do to one side, you have to do to the other. So we got x by itself. So x equals 9 minus 3y all over negative y. 9 minus 3y all over negative y. Done. Here we go again. Sorry. Just want to make it neat stuff, but you can really read it. 9 minus 3y all over negative y. Notice whenever we divided the whole left side and the whole right side. So everything is divided by negative y. So on the homework, a lot of people like to use their keyboard to type it in, but you need to, which is fine. That's how I do it. So you have to click with your mouse back and forth. But if you do that, put parentheses. So you gotta say in parentheses 9 minus 3y. Parentheses group things together. So it's grouping this 9 minus 3y together up top. So it's saying, okay, all of that is together up top, and it's all being divided by negative y. If you put the parentheses in, it won't mark it wrong. You don't need the parentheses, just optional. Just wanted to give you that heads up because I got that on an email a couple times. All right, so we did solving equations. We did fractions. So let's go ahead and like knock out all of the bad stuff and let's do problem solving. So same thing, we're going to take what we've been doing and add on another piece. So we're going to take solving equations and then add on a context, add on a situation. So almost done with this super long section. So problem solving. It says the sum of 3 consecutive integers is 246. List the numbers from smallest to largest. Okay, let's break this problem down. So there's a lot going on. So it says the sum. Sum means we're going to add 3 consecutive. Consecutive means back to back. So we're adding 3 back-to-back numbers. Integers, remember integers means whole numbers. Is means it's going to equal. Is means it's going to equal 246. List the numbers from smallest to largest. Okay, so we're adding 3 back-to-back whole numbers to give us 246. This is an S. I mean, it looks like a 5, but it's supposed to be an S. All right, so let's think about this, because some people are like, oh, I'll just guess and check. That will take you forever. This problem shouldn't take you forever. All right, so let's think about this. If we have 3 numbers, 1, 2, 3, we're going to add three numbers, and it's going to give us 246. All right, so I need to see how can I make these numbers consecutive? How can I make sure that they are back to back? So, side note, I need to make these 3 consecutive integers. And this is why you don't use pen. All right, so let's just think of 3 random consecutive numbers, 3 numbers that are back to back, like 1, 2, 3. Now, be careful. So on the homework, this is straight from the homework, but everyone's homework problems are a little bit different. So yours might say 3 consecutive integers. Yours might say 3 consecutive even integers. So for even, it would be something like 2, 4, 6. Those are back-to-back even numbers. It might say something like consecutive odd numbers. So instead of 1, 2, 3, you're going to use something like 1, 3, 5. So back-to-back odd numbers. So just kind of, you might not always use 1, 2, 3. Use whatever is for your situation. We just have 3 consecutive integers, so 3 consecutive numbers are 1, 2, 3. I could use any numbers. I could use 9, 10, 11. It doesn't matter. I just need 3 numbers that are back to back. So our first number, let's call this x, because I want to take this and put this into an equation so I can solve the equation, find out our answer, move on with my life. So our first number is x. So how do I get from our first number x from 1 to 2? So from 1 to 2, I'm going to add 1. So from 1 to 2, I'm going to add 1. So I'm going to take my x and add 1. Okay, so now I need to get to 3. If x is 1, how do I get from 1 to 3? From 1 to 3, I add 2. So that would give me x plus 2. So I'm just using this to come up with the equation to fill in the blanks, so that way I ensure there are 3 back-to-back numbers. So if I get my first number, which is x, I can take that number, add 1 to get the next number, and I can take that same number, add 2 to get the third number. So this ensures that they are back-to-back numbers. And now I can fill in the blank and I have an equation. So our first number would be x, that second number would be that x plus 1, this third number would be our x plus 2. Boom, now I have an equation I can solve for x. So let me just rewrite it without the spaces and lines and all that good stuff. So if I have x plus 1 plus, so x plus 1 and then plus x plus 2 equals 246. All right, so here's my equation. So now we can solve the equations like we've been doing this whole long section. So let's combine some like terms. All right, so if I have x plus x plus x, I have 1x plus 1x plus 1x. 1 plus 1 plus 1 would give us 3x's total. So 3x. I also have 1 plus 2. Well, 1 plus 2 would give us 3. So 3x plus 3 equals 246. Now I can solve this like a normal equation. I have 2 sides of my equation. Let's get x by itself. Getting rid of our adding and subtracting first. Let's get rid of that plus 3. The opposite of plus 3 is subtracting 3. So let's subtract 3 from both sides. That way 3 minus 3 cancels out. We are left over with 3x equals 246 minus 3. 246 minus 3 would give us 243. Last but not least, it's 3 times x. I want to get x by itself. So the opposite of 3 times x would be to divide by 3. So let's divide by 3 on both sides. That way 3 divided by 3 cancels out. We're just left over with x by itself equals 243 divided by 3. In our calculator, 243 divided by 3 would leave us with 81. All right, so we got x by itself, but remember, the problem doesn't say find x. We just use x to help us come up with our answer. It wants us to find the three numbers from smallest to largest. All right, so if our x over here is 81, then our next number would be 81 plus 1, which would give us 82. Then our next number would be x, which is 81 plus 2, which would give us 83. Boom, there is our three back-to-back numbers that should add up to give us 246. So 81 plus 82 plus 83 are back-to-back whole numbers. And if you add up 81 plus 82 plus 83, that will give you that 246. So that is our answer, 81, 82, 83, in order from least to greatest. Let's keep rolling. All right, so a car dealer, you can pause it if you need to, but a car dealer recently had a promotion which they gave a 6% discount to the first 50 people through the door. If you are one of those people and the car you're interested in costs $21,800, find the discount amount and find the new price of the car. So again, we're looking for the discount and we're looking for the cost of the car. So a couple things that the question tells us. The question tells us that it gives us a 6% discount and the total cost of the car is $21,800. Two things it tells us. All right, so our discount is going to be 6%. So we're going to get 6% off. So 6% of our total. Our total is $21,800. $21,800. So I need to find what is 6% of $21,800. So in order to put this into my calculator, I need to turn this percent into a decimal. To do so, I'll take my decimal, which is always at the end, and move my decimal 2 places to the left. So this would give me, here's my new decimal, fill in the gap with a 0, so 0.06, decimal form of 6%. That word of, in math, of means multiply. So 0.06 times 21,800. In our calculator, 0.06 times 21800, so 0.06 times 21,800 would give us 1308. So we're getting a discount of $1,308. We're getting $1,308 off. So next, so I did that rounded to the nearest cent and get a whole number, we're good. Next, we need to find the cost of the car. So the cost is going to be our total, which was our $21,800, minus the discount. So our discount was $1,308. So 21,800 minus $1,308 will give us our new cost of the car, which would be $20,492. Notice it says no commas. So that is our new cost. So 20,492, no commas. Boom. Done with that one. Last one for this page. So after eating at a restaurant, your meal came to $42.50, including tax. You decide to give a 17% tip, adding it to the total meal cost. It says, let M be the meal cost. Write the equation you would use to solve this problem. And then we're going to find the total cost of the meal. All right, so it says, let M be the total meal cost. It tells us the total meal cost. In the problem. So in the problem, it says your meal came to $42.50, including tax. So that's your meal cost. So let M equal your meal cost. So our M is going to be $42.50. you decide to give a 17% tip, adding it to the meal cost. All right, so I need to find the equation to find the total. So our total is going to be whatever our meal was. Our meal. Let me see. Total meal cost. Total meal cost. So our total meal cost is going to be whatever our meal came to plus the tax. So our meal plus whatever we decide to leave her for a tip, him or her. So the total meal cost is going to be whatever our meal was plus our tip. It's like, how much did you spend at the restaurant before, like, walking out the door? So our meal, which they told us to use M for our meal cost, so that's going to be M, plus our tip. They told us that our tip was going to be 17%. So I need to find 17% of whatever my meal was. So 17% of M. 17% of M. By the way, I had someone before tell me, like, oh, you're not supposed to tip on tax. It's just for this problem. So just like we did on this previous problem, let's turn this percent into a decimal, moving this decimal 2 places to the left. Of means multiply. So I have my M plus, moving my decimal 2 places to the left, 0.17. Of means multiply, so times M. So 0.17 M. All right, so if I have M, which is the same thing as saying 1M, so 1M plus 0.17 M, these are like terms, let's combine like terms. 1M plus 0.17 M would give us 1.17 M. And that's going to be our total meal cost, 1.17 M. So now what is the total meal cost rounding to the nearest cent? So I have 1.17 times M. We know M was $42.50. So 1.17 times $42.50, $42.50. In our calculators, 1.17 times $42.50 would give us 49.725. 49.725, and it says round to the nearest cent. So cent means 2 numbers after the decimal. So after the decimal, we have our 2 numbers, so we need to round that 2. Looking next door. Remember, whenever you round, you have to look next door. Next door is a 5. 5 or higher, it rounds up. Anything less than 5 stays the same. So 5 or higher, we're going to round up. So that 2 is going to round up to a 3. So our answer is 49.73. So that is our total meal cost, $49.73. Remember, to the nearest cent for future reference is going to be 2 numbers after the decimal. All right. Almost done. One more page for this section. Not all sections are this long, I promise. All right. Last 3 examples. We can do it. So it says convert 5 degrees Fahrenheit, 2 degrees Celsius. Use the equation. 1 second. Okay. Convert 5 degrees Fahrenheit to degrees Celsius. Use F equals 9/5C plus 32 for the conversion between Fahrenheit and degrees Celsius. So it tells us convert 5 degrees Fahrenheit. So 5 degrees Fahrenheit is telling us that 5 equals, our F value is going to be 5. Our F value is going to be 5. All right, so let's plug it in. So F, which is 5, equals 9/5C plus 32. you want to put the parentheses around the 9 over 5, you can. It's just showing that 9 over 5 is its own fraction. All right, so now we have to solve this equation just like we did before. So we have two sides of our equation. We want to get c by itself. Let's get rid of our adding and subtracting first. Let's get rid of that plus 32. The opposite of plus 32 is subtracting 32 for both sides. That way 32 minus 32 goes away. We are left over with 5 minus 32. 5 minus 32 would leave us with negative 27. Do it in your calculator. Equals 9 over 5 times c. 9 over 5c. All right, just like we talked about before, remember 9 over 5 is the same thing as saying 9 divided by 5. So what's the opposite of dividing by 5? To get rid of this fraction. We don't like fractions. Let's get rid of it. So the opposite of dividing by 5 is multiplying by 5. So let's multiply both sides by 5. That way our 5s will cancel each other out. So 5 times negative 27 would leave us with negative 135. Use your calculator. Negative 135 equals our 5's canceled. We're just left over with 9c. 9c. Almost done. So I want to move that, get c by itself. It's 9 times c. I'll move that 9 to the other side of the equation. The other side of the equation means do the opposite. The opposite of multiplying by 9 would be to divide by 9. So divide both sides by 9. That way our 9's cancel each other out. We are left over with negative 135 divided by 9, which is negative 15, equals c. So our Celsius is going to be negative 15 degrees. So filling in the blank in the homework, negative 15 would be our answer. We got c by itself. Two more. So if the length of a rectangular field is 32 feet less than 5 times its width, and the perimeter is 332 feet, the length of the rectangular field is blank feet. All right, so let's see what's going on here. First, I have a rectangular field. So let's draw our rectangular field to give us kind of a good visual. All right. It says that the length is, so equals, use this. So the length is or equals 32 feet less than 5 times its width. All right, so be very careful with the way it's worded. So the length, which is this long side up here, so the length is or equals 32 feet less than 5 times the width. So whatever 5 times the width is, so 5 times the width, let's say 5 times W, we call the length L and the width W. 5 times it's, so 5 times width, and it's 32 feet less than that. So whatever 5 times the width is, minus 32 feet. So the minus 32 goes to the end. So 32 feet less than 5 times its width. So 5 times the width minus 32. So if that's the length, that means that this on the bottom is also our length. So 5W minus 32. And then this up and down would be our width. So those would be both W. It says the perimeter. Remember, our perimeter means that we're going to add up all the sides. So if we add up all the sides, we have 332 feet. So now that we have each side labeled, let's write our equation. Let's add up all the sides. So this first side, which is 5W minus 32, plus our width, so plus W, plus this other 5W minus 32, so plus another 5W minus 32. And then last but not least, plus this other width. So 5W minus 32 plus a width plus 5W minus 32 plus a width. Adding up all the sides will equal 332. All right, so boom, we have our equation. So for this equation, let's combine some like terms. All right, so let's see. 5w minus 32 plus w plus 5w minus 32 plus w equals 332. Let's combine all of our w's. So 5w plus 1w plus 5w plus 1w. So 5 plus 1 will give us 6, plus 5 more is 11, plus 1 more is 12. We have 12w total. And then let's add, we have negative 32 minus 32. Those are like terms. So negative 32 minus 32 would give us negative 64. So 12w minus 64 equals 332. So now I have my equation. Let's get w by itself, everything else to the other side equation, and then we have our width. So getting rid of our adding, subtracting, let's get rid of that minus 64. So the opposite of minus 64 is adding 64 to both sides. That way negative 64 plus 64 cancels out. We are left over with 12w equals 332 plus 64. 332 plus 64 would give us 396. Now, I'm not like some crazy math person. I did all this on a calculator beforehand just to kind of save time. So use your calculator to help if needed. So 12w equals 396. Last but not least, getting w by itself, it's 12 times w. So let's do the opposite. Let's divide both sides by 12. 12 divided by 12 cancels out, goes to 1. We're left over with w equals 396 divided by 12. 396 divided by 12 would give us 33. So we know that our width is 33. The question doesn't want our width. The question wants our length. We know that the length, or L, is 5w minus 32. Well, now that we know our w is 33, we can plug that in. So 5 times our w, which is 33, minus 32. I can plug this into my calculator just like this. 5 times 33 minus 32, and that would give us 133. And then notice we're talking about feet, so 133 feet. So up here in the blank, we have our length of the rectangular field is 133 feet. Last example for this section. Hey, okay. So it says a high-speed boat travels from the mainland to an island 170 miles away in 5 3/4 hours. What is the boat's average speed? If necessary, rounded to decimal places. All right, so notice right there. It says decimal places. So that means I can put this 5 3/4 into a decimal. So I know in my calculator, 3 divided by 4 would give me 0.75. So 5 and 0.75 would give me 5.75. So that fixes that right then and there. So again, in my calculator, 3 divided by 4 would give me 0.75. So 5 3/4 would give me 5.75. All right, so I have my speed is miles per hour. So they tell me in the problem that I have 170 miles. So that's my miles. And I have 0.57 hours. So speed is in miles per hour, and this hint, use the equation distance equals rate times time. Distance equals rate times time. So our distance that they gave us is 170 miles equals our rate. Our rate is speed. Our rate is our speed. So we are trying to find what is the boat's average speed. That's what we're trying to find. So we don't know our average speed, so let's call that x. Times our time. They told us our time is 5 3/4 hours, or in decimal form, 5.75 hours. So 5.75. All right, so I'm going to try to get x by itself. X is being multiplied by 5.75. So in order to get x by itself, we can divide both sides by 5.75. That way 5.75 divided by 5.75 cancels out. We have x by itself, which is what we wanted. In our calculator, 170 divided by 5.75 will leave us with 29.565217, blah, 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 whatever. 29.565217, blah, blah, blah. We got x by itself, which is great. So we have x equals, remember x is our speed, which is what we were looking for. Our 29.565217, it said rounded 2 decimal places. So I'll look at the second number after decimal, 2 decimal places. Remember, you look next door, 5 or higher, it rounds up. Anything under 5 stays the same. If I have 0.565, so this number next door is 5, 5 or higher rounds up. So it means this 6 is going to round up to 7. So I have 29.57, so it rounds up, is our speed. It tells us in the problem that speed is in miles per hour. So our answer is 29.57 miles per hour. 29.57 miles per hour. And that is all of Module 1 Homework 1 notes. Thank you for watching. Now, after you completed this video, go through and complete your Module 1 Homework 1 homework assignment, which should look just like this, might have different numbers, but same concept. Good luck. Let me know if you have any questions. Thank you.